For the next one, we will have Sergey presenting the comfortable complexity of overlays. Sergey is a network engineer at Arista Networks, supporting hyperscale infrastructures for AI, DC, DCI, and enterprise customers. He has traveled here from Vancouver, Canada. Please join me in welcoming Sergey to the Nanox stage.
Thanks. Great, thank you. Today, I'd like to talk to you about a few topics related to overlays and cover that from perspective of my own experience being in the industry, both from the vendor side and also on the operator. I'm presenting on behalf of myself and my colleague Altan. Unfortunately, he couldn't make it today, but I'll try to cover for both of us. I'll start from identifying some future directions and what probably worth paying attention to and what we can leave for the history, because we know that evolving needs in multiple use cases, would it be AI, machine learning, HPC, cloud, large-scale data center or enterprise, we see that L2 transport requirements are evolving as evolving the applications that are more intelligent with regards to the network and transport that we are providing to them. Modern databases and services, they all rely on primarily IP for rare exceptions, and IPv6 adoption is on the rise. So we know that with V6 in the underlay is at least not just a good practice, but very common deployment for greenfield build-outs. And it provides very natural path for future directions, such as SRv6, as we can see it being adopted in multiple places in our networks, including some of the most recent machine learning AI use cases with the introduction of SRv6 microseeds. And another very important point which I'd like to stop today is about unified control plane and simplification, as well as the optimization of the management of our networks. And legacy brought us complexity. There was lots of options for the control plane and the whole plethora of unique solutions. Some of them were vendor-specific, some of them were running concurrently in ATF, addressing the same use cases, providing IP and Ethernet services, but still wouldn't solve all of the problems, but keep the complexity in place. So the multitude of the control plane signaling models didn't make our life as network engineers easy, and there was a requirement to provide some unification and overhaul of those solutions. And during my career, for the last 15 years, I was able to observe and also participate in some of the developments related to overlays in EVPN in particular. Starting from L2 services such as Ethernet LAN or Ethernet line, we, over the last 10 to 12 years, end up with close to 50 concurrently running drafts and RFCs in ATF related to EVPN. So we have a huge response from the market and amazing participation primarily from all of the vendors. And in a way, we have replaced the complexity of the past with close to 50 concurrent drafts and RFCs with VPN. But my point here is that EVPN is a single control plane management in comparison to the legacy where we had absolute dispersion of those options. And I would say that networking industry, from my perspective, exists in a very dynamic market. Technological trends exist probably 10 to 15 years, and things like virtualization, disaggregation, convergence seriously impacted the networking industry as we are building solutions according to the requirements that we have in our use cases. So with the introduction of virtualization, in particular, any service anywhere and the requirement to provide L2 services has been in the works and still exists till nowadays. And for example, I would say that L2 services would be required in many places in the network in multiple verticals. One example could be in a data center, while modern data centers are built primarily on L3 leaf spine with either just plain IP, or if you need to provide multi-tenancy, it would be EVPN plus VXLAN. However, L2 requirements are still in place, and EVPN with VXLAN can easily be an answer to that. Data center environments usually related to providing services for virtualized applications, and we constantly moving them around, virtual machines spinning up and down and doing the migration, Docker containers or any other management tool for the containers spinning up and down. So it created quite a demand on the switches side as well, because in the past we used to build applications more of a monolithic approach where we had one physical host equal to one application. Nowadays, one physical host means hundreds of MAC addresses, hundreds of MAC IP bindings, and they also moving around constantly within the network, and we need to support that from networking perspective. And I would say that multi-vendor effort to solve that, such as VXLAN, has been an answer for it for the last decade or so. In the enterprise use cases, where traditionally we saw L2 environments and router on a stick approach most of the time, currently designs are built around L3 in the underlay and providing both L2 and L3 services in the overlay with VXLAN and EVPN. And it's usually an environment where we have multiple tenants but single administrative domain, and isolation is provided per tenant, per domain, and per host within that domain. So traditional perimeter security architectures of the past are not working really well anymore, because we introduced mobile devices and cloud technology, and control that perimeter is very hard this way. So privileged internet couldn't be accessible by users and hosts based on the source network they are connecting from anymore with that new approach, where we creating policy enforcement points such as switches and firewalls, and providing host-based segmentation with dynamic access control based on contextual factors. So centralized observation and logging of all the data movement in the enterprise network is more of a norm. This is where EVPN VXLAN E3 with VXLAN group policy extension providing a very good solution for that as well. In the HPC, AI machine learning use cases, based on my personal experience, absolute majority of all deployments are built on L3 natively. However, there is still legitimate L2 use case there as well. Some people would argue that CPU-based software kernel dependency makes TCP/IP too slow, and especially on the large fabrics with respect to workloads related to AI. So Tesla presented their TTP over Ethernet protocol last year on Hot Chips conference and already published the source. So they wanted to build low latency, high bandwidth, simple software, single application, and rely just on L2 because it is purpose-built solution, purpose-built infrastructure for them. They do not rely on IP headers at all. There is no IP in the header of the packet whatsoever. But however, they still need to interconnect hundreds and thousands of GPUs in the same fabric. So just stretching it out with one large VLAN probably would be not a great idea. So relying on L3 in the underlay and utilizing all the whistles and bells that EVPN bringing in to properly control BAM traffic and just generally control broadcast would be useful there as well. In telco and cloud use cases, usually we can boil it down to multiple tenants with multiple administrative domains, and they usually interconnect dispersed location and combine data centers in one solutions. So we have to deal with a combination of the transport there. Usually it is IP in the data center and MPLS in the WAN, and we need to interconnect it somehow and perform the service chaining and also preserve the original design that we have in a data center and translate it to the rest of the data centers there as well. So it probably would be a good idea to rely on EVPN here to stitch those different transports, and I will talk about the extensions in EVPN in particular that allow us to do that with EVPN gateway extensions. And in addition, EVPN allows us to add functionality of load balancing by introduction of the route type 5 gateway index functionality, as well as provide with the options to scale those solutions out. And I will talk in details about those details, but one thing that probably worth mentioning here is in the past I had experience working on the operator side before joining the vendor, and multi-homing options, which in the past at least were dependent primarily on the vendor specific developments, would create some problems in the life of network engineers. So for example, if you have rack 1 where you had hosts in a multi-vendor environment, multi-home to multi-chassis link aggregation, pair of switches, and the rack 2 where you have multi-homing to VPC, interop would be hard. However, with EVPN and the introduction of Ethernet segment, this problem is solved, and it also provides additional benefits such as ECMP in the underlay where shared IP address across all of the VTAPs where the hosts are connected and multi-home to reduce control plane dependency and also faster route in the event of local link failures. Speaking about the gateway functionality in the EVPN, it is a service which provides us with a solution for a variety of use cases. And let's imagine a use case where we migrate in a traditional STP-based router on a stick type of environment to something more scalable and also dependent on L3 in the underlay. We could utilize centralized gateway functionality there, where traffic would be VXLAN encapsulated and bridged towards a centralized gateway, where the inter-VNI, inter-VRF routing will be happening. This is a standardized approach, so you can expect that multi-vendor solutions interoperable. And I think it is actually a very good option for migration options. These use cases are usually required where we have gateway inspecting traffic with large-scale ACL or firewall rules, so you cannot really deploy them on all of your VTAPs because you will have to depend on more complex and more expensive hardware rather than have centralized gateway who can do that for you, or at least be a service VTAP connecting to the firewalls. So where else do we need VPN gateways, and where and how we can use them? I think because it is standardized, it is an option for us to scale out, and we'll talk in details how we can do that, what extensions VPN provides for that. It also gives us option for transport transition between different types of encapsulation and service migration, and the interop, of course, there as well. So speaking about the hierarchy, let's assume we have a requirement to support a very large number of top of racks or VTAPs in our network, and we need to stretch L2 VLANs across a majority of them, and also make it happen that our solution is not extremely expensive. So our VTAPs will be less dependent on more expensive hardware. By introduction of EVPN gateway functionality, we can divide our domain into multiple EVPN domains, introduce logical roles such as just general VTAPs and VTAPs which can be gateways for a given EVPN domain. And we do not need to know about behind which particular VTAP in the remote domain a specific MAC or MAC IP binding is located. We can just know how to reach it, and the next hop for it would be our gateway in the local EVPN domain, which will significantly reduce TCAM utilization, software RAM utilization on your VTAPs, and you can build larger deployments and in more controlled environments there as well. And adding there as a bonus point that we can also do interconnect across VXLAN or MPLS in the core existing on the same device, which is a gateway. I think it's a prime use case for this. And speaking about the interop, right, I think it's one of the main points of my presentation here is that EVPN not only providing us with single underlay solution or overlay and underlay solution there, but it also can be helpful when we need to support multi-vendor environments. European Advanced Network Test Center runs tests every March and publish results in April. They are available to everyone. Majority of vendors will participate in a lot of use cases, including interop with respect to VXLAN, MPLS, RV6 with EVPN as a control plane as well. You can talk to your favorite vendor about their experience and maybe the lack of one, and ask them for maybe the configuration that they have used there, because fortunately NDC cannot publish that. But if you need to, for example, assess a new deployment, a migration strategy, and you need to assess where a particular vendor is currently with respect to the support of the functionality you needed, you can probably refer to those test results, which are again publicly available, and make the decision based on that, and then talk to the vendor, run POCs, run canary testing, and so on and so forth. Redundancy models in the gateway, we tend to have, besides vendor-specific implementation, two other options: Anycast AP versus all-active. One of the previous presentations mentioned something about all-active current support. In my experience, I see majority of use cases relying on Anycast AP, and there are pros and cons, and it's not about what's better. It's about how many tools we have in the toolbox to address our specific use case here. And the difference would be, would you be able to support SMP in the underlay versus overlay, and can you connect directly attach hosts to your gateways there? It's a standardized approach, both of them, and you can expect feature parity between them going forwards as well. Extensions and how they help us to scale solutions and manage our networks. Unknown MAC route, one of the relatively recent additions. Think about default IP route in the routing, in this case a default MAC route. So in some use cases we do not need to support MAC mobilities between devices in our network. We can divide our network in multiple EVPN domains, and we can just install default MAC route from the gateway into a specific domain and forward traffic towards that gateway if we do not know the destination, the location of this, that MAC in the destination. So really good tool or really good extension for scalable solution. Another thing to highlight is DPass, extended community support for EVPN route type 5 routes, which is working on inter-domain cases as well. Works in a very similar way to IBGP route reflector cluster ID and helps us to prevent loops of EVPN information exchange between the domains. And probably touching base on something related to combination of different deployments of options of EVPN gateways. We don't necessarily need to depend either on L2 gateway or only on L3, as we saw in different slides just before that. We can actually combine them together, and if we need to support a very large scale network with stretched L2 across a lot of VTAPs, and also rely on, for example, extremely large scale ACLs for traffic filtering and control, we can divide our network from L2 perspective into multiple EVPN domains by introduction of L2 gateways, and route all the inter-VNI, inter-VRF traffic through L3 centralized gateways. And from their perspective, from the perspective of L3 gateways, they don't necessarily even need to know that we have divided our network into multiple EVPN domains from L2 perspective. It still looks like one flat network from their perspective there as well. And we can rely on BAM control with ARP-ND bridge functionality on our L2 VTAPs. And again, this an excellent opportunity to support larger scale deployments. I will also probably share that use cases related to multicast. Gateway functionality with OSM, which is significantly optimizing solutions for multicast flow, and we now able to deliver the single copy of multicast only to the interested VTAPs by introducing additional route types in EVPN advertisements and significantly improving the performance in comparison to PIM-SSM versus ingress replication with underlay multicast as we used to do that in the past. There is also other components involved here, such as SBD, which is shared L2 VNI between all of the OSM provider edge devices, and there is also distributed multicast designated router across all of the VTEPs versus just one in original deployments and developments without OSM. And in conclusion, with respect to the EVPN gateway functionality, I think it would be fair to say that gateway can work in comparison to, for example, OSPF ASBR, OSS dynamic flooding with area proxy, but in EVPN. It's a bit of a stretch, but there is a comparison between them. And the gateway functionality allows us to provide L2, L3 EVPN services over the L3 underlay, which means we can scale, we can interop, we can re-advertise route types between different domains, irrespective of the underlay transport. And we can rely either on any cast IP or active-active options for multi-homing. And as mentioned before, it also will be interoperable solutions between multiple vendors. In conclusion, I will say that I can see from my perspective in the industry that L2 services still required. We can see them required in many places in the network. Would it be data center? Would it be enterprise, WAN, or I don't know, AI, machine learning type of design, and across multiple verticals as well. And L3 Fabric is the norm, and providing L2 and L3 services over L3 Fabric is not just a good practice, it's how networks are built nowadays. Legacy brought us a whole plethora of dispersed solutions, but some problems were still not solved, while the complexity was kept in place. And overlays based on the IP fabric are now possible to manage with the same control plane, and would it be VXLAN or MPLS in the transport. And we have a standardized approach to the solutions and the consensus among many vendors, which can drive forward customer value and investment protections as well. So we can have shared control plane solution for many places in the network, and complex set of use cases now can be solved with the solution based on the same control plane, which is EVPN with BGP signaling. And I'm personally very glad that we have a whole toolbox of extensions to EVPN, and that can help us to bring the solution to the table, and would be one of the best solutions out there. Thank you for your attention.
Thank you for your presentation. We have a remote question from Mahesh Parmar. The question is about the overlay support among the vendors. How widely it is supported?
I'm sorry, I couldn't get it. Could you repeat, please?
Yeah, sure. So Mahesh is wondering whether all major router vendors support the overlays feature.
For some reason, there is some problem with
volume. How many vendors supporting the overlay feature?
Right.
How many?
What vendors are supporting?
I think the best source of that information will be ENTC testing results. And it will tell you not only which vendors participate and support it, but also how well they support it.
Thank you.
Any other questions in the room?
There is some.
Hello, Patrice Brissette from Cisco. Good presentation, thank you. You did show all the work we did, for the community and everybody for a long time. In your mind, what's missing?
Can you repeat the last part?
So, with the presentation, you've been showing us a lot of things that we did for EVPN, right? So, in your mind, is there something missing there?
From perspective of the presentation or EVPN in general, I guess.
Both, I guess.
Once I come across that use case in my practice, I'll probably add it as a slide. But for now, that's my perspective, and I've tried to be as honest as possible about it.
Thank you, Sergey, for the presentation.
Thanks.
We appreciate your contribution.